Hello guys, welcome to second law of thermodynamics, a very important topic again, diesel engine. And this is the working system of a diesel engine or the cylinder of the diesel engine. So here it has inlet valve to let in the air. So in petrol we let in the air and the petrol vapor, but for here in the first step we only let in the air. Then second is the oil spray valve, which will spray the oil vapor. And now the exhaust valve, which releases both air and the oil vapor. So I'll be drawing the diesel cycle graph. So if you understand this graph, then it will be very easy for you. So first, it is also the 4-stroke engine with the same stroke names as that of the petrol engine. So first of all, we have suction stroke. Now for here, again, inlet valve opens, only air gets in and the piston moves outwards, thus there is an increase in volume at constant pressure. Now a tip I'll give you for you guys is that if the one of the valve is open and volume increases or decreases, then the pressure remains constant. So here this is represented by OA. So now the compression stroke. Now here it is the same thing. The inlet valve closes and the piston moves inward, thus there is a decrease in volume. But the difference in diesel engine is that it compresses very much. It has a high compression, thus there is a high increase in pressure as well. That's why in this figure or in diesel engine there is no spark plug, because the goal of the spark plug is to ignite the mixture to increase the temperature so that the heat engine could operate. But here, since the compression there is a high compression, it does not need a spark plug to ignite the mixture, because the high compression already raises the temperature to a high level so that the working substances already get ignited, which operates the heat engine, which is the diesel engine. So here, yes, this is how much it compresses. So let's say this goes to a point B, and let's just say that this, sorry, at this point, at point A, let's say this is volume 1, this is volume 2. So first, here, this goes from A to B, pressure rises to 35 atm, and temperature rises to 1300 degrees Celsius. Now, the compression ratio, which is V1 by V2, is almost equal to 16. That means during compression, it compresses to 16th of its original volume, 16th. And you may get a conceptual question that why is diesel engine used mainly by heavy vehicles? Well, to withstand this high compression, the outer or the cylinder of the diesel engine is made thick and strong. So thus it is used in heavy vehicles. Now for the third, which is the working stroke. So at point B, I'll write it right here. At point B, now the oil spray valve gets opened and the oil gets sprayed, and at the same time the piston moves outward. And since the valve is open, there is a constant pressure like this up to point C. And due to the spraying of the oil, the system or the engine gets absorbs heat Q1. So here this is BC, and now from point C again, for here the oil spray valve and the air, due to the high temperature, the mixture gets on, and this is called combustion. BC is called combustion. And at point C, the oil spray valve is cut off, so the supply is cut off, and it is known as cut-off point at point C. And due to this cut-off point, there is a decrease in pressure because there is no more oil, and at the same time the volume also increases. That means that there is very low in pressure, and volume also goes here to point D. Now this is plus CD, So overall we get BCD, that is the working stroke. Now for the last one, it is known as the exhaust stroke. And it is the same thing as in the petrol engine. Here the exhaust valve opens, which is basically the outlet valve opens, and the working substance gets released. That means, well, the pressure decreases, right? Because they went away. And this step, which is D2A, is called release. And here the piston remains fixed, so that's why there is no increase or decrease or change in volume. And now again, from A to O, the piston moves inward, keeping the exhaust valve open. Thus there is a constant pressure and it goes all the way back to O. So this is AO. So we have D, AO, and thus, well, the diesel engine is ready for another cycle. So here the efficiency is given by 1 minus Q1 by Q2. Sorry, here also heat releases due to, well, it loses heat Q2 because exhaust valve opens and the working substance is released, so heat is released into 100%. And again, this, well, because of some derivation formulas that we don't need, becomes 1 minus 1 by compression ratio into the power gamma minus 1 into 100%. Now gamma is the ratio of the specific heat constants, and in the petrol engine video I forgot to mention that the value of the gamma is 1.5. Now this here, this is approximately equals to 16 and gamma is approximately equals to 1.5, and therefore, well, the efficiency is almost equals to 62%. But here practically, so I'll write practically, in the real world the efficiency of the diesel engine is only 30%, well, near to 30%. So yes, the diesel engine performs better than a petrol engine, but it has to be used in heavy engine, and yeah, it must have an engine with, well, thick and strong layering, right? And that is it for diesel engine, and I'll see you in the next video. And if you learned something new, please like and subscribe. Thank you.